Alright, today we're going to start talking about the normal curve in section 2-2. Whenever we talk about the normal curve, we always have the N capitalized because it's that darn important. And it's going to be something that we see very often as far as statistics go. So the normal curve, like I said, has a curve that looks like this, where it's symmetrical. And it has one peak, and it's basically goes up in the middle and then down on the right side. The mean is right in the middle, and if you basically, for those of you who are in calculus, when it turns into a hill into a valley, that's called a point of inflection. But for those who don't, basically from the center to that point where it changes from a hill to a valley, then the mean is about what the standard deviation is going to be. The normal curve is used in a lot. Most definitely it's used when taking a large exam like the SAT or the ACT, where a lot of people get scores in the middle but few get scores on the end. And it's going to turn out to happen a lot here in statistics. And we must talk about the fact that even though we're going to see a lot of things that are normal, not everything is normal here in statistics. So let's move on to talk about some things we know, or we're going to know about the normal curve. Alright, so here I drew another normal curve with mu in the middle. And if I go one standard deviation on each side and put a little barrier, so this is -1 standard deviation, that's +1 standard deviation. Inside here is going to be 68% of my data. Approximately 68% of the normal distribution is in between -1 standard deviation and 2 standard deviations. Now, if I go out another standard deviation in each way, so that's 2 standard deviations, 95% of the data is in between 2 standard deviations. And if I happen to go out a third standard deviation, we will have 99.7% of our data in between 3 standard deviations. Now this is different from Chebyshev's rule because Chebyshev said any distribution. But if our distribution is normal, then these are the percentages that are within the 1 standard deviation, 2 standard deviations, or 3 standard deviations. It's called the empirical rule. Alright, we're going to start out with a nice simple question, and then we'll move on to a little bit harder. Let's say we have a standard or normal distribution where the mean here is equal to 10 and the standard deviation is equal to 2. So that means 12, if we're going in between 12 and 8, well 12 is 1 standard deviation up and 8 is -1 standard deviation. So we're talking about all the information between the -1 and 1 standard deviation, which based on the last part, we know that is 68%. Alright, the next problem we're going to do is we're going to do the percentage that is less than 6. So here's 10, here's 6, which is -2 standard deviations, and so I want to know what percentage is in here. Well, if I go up 2 standard deviations, how much is in the middle? 95%. So that means that I have 5% left over. Well, if I have 5% left over, and this is symmetric, I'm going to put 2.5% in here, and 2.5% in here. So that means that my answer must be 2.5% of the data is less than 6. Alright, we'll try one more here. This one is the toughest. What is the percentage between 8 and 14? So here's my curve. Here's 10. 14 is 2 standard deviations up. 8 is 1 standard deviation down. So, how are we going to figure this one out? Well, let's just worry about this part in red first. Since that is one standard deviation away, it should have been 68% if it was on both sides, but because it's only on one side, that part's going to be 34% because this is symmetric. On the other side, in green here, that's two standard deviations, which was supposed to be 95%, except for we only have the stuff on the right in green. So if I take 95 divided by 2, that's 47.5%. So, since we can combine the green and the red here, we're going to take the 34 and add the 47.5, and we get a total of 81.5% of the data. So there's several ways to kind of figure this out as you're going through. These were just 3 examples of what we can do with all of these. Obviously right now we're only working on ones that hit exactly on the standard deviation, as that goes along with the empirical rule. We'll see other ones later.